Hello children, Motion, Class 9, Subject Science, Chapter 8 and this is the part 3. So what we learned in the previous video? So we have studied about the uniform motion and a graph, velocity time graph and the SI unit of velocity, right? And we have studied about the definition of uniform motion. So what do you mean by that? The object which is moving equal distances in equal intervals of time is called as uniform motion, right? And in today's class, let us study about non-uniform motion. So look at this figure. So in this traffic, the vehicles are required to stop and then move in traffic, thereby traveling unequal distances in equal steps of time. Hence, it is a non-uniform motion. Okay, so let's recall about the uniform motion. Uniform motion means what? Covering equal distances in equal intervals of time, right? So non-uniform motion is exactly the opposite of that, which means what? Covering unequal distance in unequal intervals of time. No, it's wrong. Okay, it is nothing but covering unequal distances in equal intervals of time. Okay, so the time has to be equal in order to know. Is it clear, children? So non-uniform motion is nothing but covering unequal distances in equal intervals of time. So what is non-uniform motion? Non-uniform motion is the motion in which an object travels unequal distances in equal intervals of time, however small the time interval may be. So the simplest case of non-uniform motion is motion under a constant acceleration on a straight line, which is one-dimensional. Okay, so this is nothing but the simplest case of non-uniform motion. So let's take the same example just like we did for uniform motion. So a car is at point A at time 11:55. That is, it is at rest. So what happens? So after 5 minutes, the car has moved from A to B covering a distance of 1 kilometer. Next, at 12:05, so the car has moved from point B to point C covering a distance of how much? 2 kilometer. And then at 12:10, the car has moved from C to D covering a distance of 3 kilometer. And at 12:15, the car has moved from D to E covering a distance of 4 kilometer in this case. Yes or no, children? So here what happened? Thus the car is said to be in non-uniform motion. Why? Because at equal intervals of time, it is covering unequal distances. Okay? Graphical representation of non-uniform motion. So given below is the tabular form of the data of the unequal distances covered in equal intervals of time, right? So the time remains same. So for each 5 minutes, we are calculating how much distance the car has travelled. So in first 5 minutes, it has travelled 1 kilometer, and in the second kilometer, in the 10 minutes, it has covered total 3 kilometer from the initial point, and in 15 minutes, it has covered 6 kilometer from the initial point, and in 20 minutes, it has covered 10 kilometer from the initial point. So let us plot a graph on the basis of tabular data to see the nature of motion of the car. So here, can you all see the dots here? Yes. So when we join all those dots, we get a curve. Is it clear, children? So let us see few more examples of non-uniform motion. Dropping of a ball. So non-uniform motion of a ball because the ball covers unequal distances in equal intervals of time. Yes or no? Ball moving down on an inclined plane. So what happens when the ball is moving? So it covers unequal distances in equal intervals of time. Free fall. Non-uniform motion of a ball because the ball covers unequal distances in equal intervals of time. So those are few examples for non-uniform motion. And now let us study about the acceleration. So what do you mean by acceleration? Acceleration is the rate at which velocity changes. Okay, so it is a vector quantity because velocity is also a vector quantity. Therefore, acceleration is nothing but the rate at which velocity changes. Rate means what? With respect to time. Right? So, since velocity is a vector quantity, acceleration is also a vector quantity. And the unit of acceleration is meter per second square. Okay, please remember this. Velocity, what is the unit of velocity? It is meter per second. So, with respect to rate means again one more second. Therefore, it is ms power minus 2. So, now let us study about the acceleration and deceleration. Okay, so if an object speeds up when the acceleration and velocity vectors point in the same direction. So, whenever the acceleration and velocity vectors have opposite directions, the object slows down and is called as decelerating or retarding. Did you all understand, children? So, when the acceleration and velocity vector point in the same direction, then what happens? The object speeds up. Therefore, we say that it is accelerating. And whenever the acceleration and velocity vectors have opposite directions, the object slows down and is called as decelerating or retarding. Okay, deceleration is nothing but the negative of acceleration, which means the opposite of acceleration. So, what we learnt in this video? So, about non-uniform motion, and we have studied about the graph and the SI unit of acceleration and retardation or deceleration. So, here are few questions that you have to answer. Please pause the video and then try to answer. And the answers for all these questions is in the last slide. So, please go through it after answering. Is it clear, children? Thank you.